recording. I apologize. But I just started it.
Okay.
So they've said f double prime of 0 equals, what was it, 7?
7, yeah.
Well, that means 7 has to equal minus 2 cosine of 1/2 times 0. That's what they're saying, is when x is 0. 7 is equal to that. Okay? So that's going to allow me to solve for c. What is the cosine of 1/2 times 0?
Just cosine 0, which is 2 pi? No, it's just 0, I think.
It's 1.
No.
In other words, here's your cosine curve. Cosine of 0 is 1.
Yeah.
Cosine of pi is -1. Those are key points on your cosine curve that you really want to memorize, because especially with calculus, you're constantly having to figure these out. So I've got 7 equals minus 2 times 1 plus c. So c equals 9. Okay. And if c equals 9, I'm going to go back up into the second derivative and substitute. It's no longer c, it's 9.
Okay.
Okay? And we're just going to go backwards until we get the right answer. Now, that's why I asked, how come they didn't give you an f prime? Now, let's find f prime of x.
All right. Would that just be...
Start with what you see.
So it'd be -2 sine 1/2 x over...
Divided by this coefficient, which is 1/2, which is the same as multiplying it by 2.
So it's -4 sine 1/2 x?
And then take the derivative of that real quick.
It would be -2 cosine 1/2, so it works.
Right, okay. What's the antiderivative of 9?
9x.
Plus c. Okay. Now, the fact that they did not give us f prime of anything, it's called an initial condition. Okay? They gave us an initial condition for f double prime. And that initial condition, it doesn't always have to be 0, but it's some value that we can plug in for x and calculate c. Because every time you take the antiderivative function, you have a c. And the next step is to figure out what c is. Okay? In other words, I guess I can try to solve this without that. They didn't give us any f prime of anything.
Yeah, they
The
didn't.
was f of 0 equals 1. It must have given you an f prime of something.
It doesn't look like it here.
Okay. Well, I don't think you can progress any further here. Well, let's figure out what f of x is. Start with that. It's got to be cosine, which changes that to a plus. Divided, multiplied by 2, which changes that to an 8. You with me?
Yep.
What's the antiderivative of 9x?
As much as 9x squared over 2.
Yeah, I always do these antiderivatives the same way. When I'm using the reverse power rule, I start with the exponent. I start with the coefficient. Then I add 1 to the exponent and divide by the new exponent. That's it. Add 1 to the exponent and divide by the new exponent. Okay. Well, my c becomes whatever c was. I'm going to call it cx, which, if we knew what it was, it would now be cx. Okay. Plus c. Only this C might be different than this C, so maybe I'll call that D, some number. Okay, now they have told us that f of 0 equals 1? Yeah, f of 0 equals 1. So if I take this expression, notice that when I plug in 0 for x, I'm going to be able to solve for D.
Yeah.
No, I won't. Yes, I will. All right, let's see. What is f of 0? Cosine of 0 is still 1, so that's 8 plus 0 for the 9x squared over 2 plus 0 for the cx plus d. That's f of 0. So d is equal to minus 8. So I assume the final question they're asking is what is the original function, correct?
Yeah, it's just asking for what f of x is equal to.
That's all I can figure out right there. I don't know what that C is, and I don't think we're supposed to be able to know what that is. I think they forgot to give you an initial condition on that.
Yeah.
What we basically are looking at here are differential equations. They're giving us, this is dy dx. In other words, they gave us the third derivative, but they could have just as easily given us the first derivative, f prime, and wanting us to get the original function. Well, these problems always have an initial condition that allows you to solve for C.
Okay.
Now, we got most of the function, but getting this C, that C could still be any number. It doesn't have to be anything. It's a variable. And I don't think that's the solution they were looking for, but maybe. Who knows? Okay. What else you got?
All right. There was one more on that one, and it's kind of the same type of one. It gives you the f double prime.
Okay, this is more typical, and I'll tell you why. Because f double prime is the second derivative, and that's also acceleration.
Okay.
First derivative is velocity, and then you have acceleration. Well, there is a third derivative to motion, and that's jerk. But most people aren't really familiar with it. Most people are very familiar with velocity and acceleration.
Yeah.
So with any problems involving motion, you will frequently get the second derivative and an initial condition. What's the second derivative?
So it is, f double prime of x is e to the 4x minus 1 plus cosine 4x. And then it gives you f prime of 0 equals 7.
Okay, let's have you do this. I think
F of 0 equals 4. It gives you 2.
Okay, good. I need both of them. In other words, this first one's going to allow me to figure out what f prime of x is. The second one's going to allow me to figure out what f of x is. Okay. Unless there was something I missed on that last problem, I don't know how you do it without the initial condition at each stage.
Yeah.
But what's the antiderivative of e to the 4x?
Is it e to the 4x over 4?
Yes, same concept. You find the antiderivative of that, and then you divide by the derivative of the inside. As long as it's a constant, you can do that. You can't do it if there's a variable. In other words, if it was that, can't do it. Then it becomes an entirely different problem. Amazingly, how much more difficult it is to solve this problem than this one.
Yeah.
Okay. What's the antiderivative of 1?
X minus x.
The antiderivative of cosine of 4x?
Minus sine, or is it plus sine x? Sine 4x over 4.
Okay, you tell me. What's the derivative of that?
It would be cosine 4, yeah, it would be cosine 4x.
Yeah. You basically, here, I can tell you one way to remember this. You have your three trig functions, and you have their cofunctions. That is the cofunction of sine. That is the cofunction of tangent, and that is the cofunction of secant. Well, the derivative of these three are all positives. The derivative of these three are all negatives. So all of the cos are negatives. And that memorizes it for you in one easy step.
So if you're trying to find the derivative of a cosine, you're saying it comes
Always
negative.
negative, okay? Here's the best way to do it. The derivative of this is the cofunction, right? The derivative of sine is cosine. Here, let's just write that. The derivative of tangent is secant squared. The derivative of secant is secant tangent. Now, as long as you memorize those three, these three are the cofunctions of every one of those. In other words, cosine is the cofunction of sine, and the derivative of cosine is the cofunction of sine. I mean the cofunction of cosine, only with a negative. Okay? Same thing with cotangent. If the derivative of tangent is secant squared, then the derivative of the cotangent is going to be the cofunction of secant squared, which is cosecant squared with a negative.
Okay.
Down here, the derivative of secant is secant tangent, therefore the derivative of cosecant is negative cosecant cotangent. So this solves itself as long as you know this rule.
Okay.
In terms of memory. And, you know, a lot of times that's all math is all about memory. It's your ability to memorize these complicated things. And this stuff is certainly complicated. It's all like a foreign language to begin with, so memorizing it becomes a little tricky. But if you can kind of memorize it in terms of cofunctions, it's helpful. Okay? Plus C. I forgot to add it. Okay? With me?
Yep.
What's the next step?
Then do you plug in the 0 for the x's?
Uh-huh. Tell me what the next line I should write is.
It would be e to the 0.
Hold on. It's equal to 7. So, in other words, f prime of 0 is equal to 7. So it's 7 that's equal to everything on the right side of the equation with 0 plugged in for x.
Okay.
Okay, so now I find the easiest way not to make a mistake here is to not try to do it all in one step. Let's plug it in. E to the 0 over 4 minus 0 plus sine of 0 over 4 plus c. All of that's equal to 7. Now solve that.
So is e to the 0 just is it 1?
Any number to the 0 is 1.
Okay,
Including 0. Including 0 to the 0 power is 1, not 0, like most people would think. So this becomes 7 equals 1/4.
And I think it's just plus c.
Yep. Everything else disappears, so c ends up being 6 3/4. Now we can go back into that function, plug in 6 3/4 for c, and we have our f prime of x. Okay? Now, to get f of x, we're just going to keep doing exactly the same thing.
Okay.
Tell me what I should write.
So you could do. Would that be would it just stay the same with?
You still have to take the antiderivative of that. In other words, right now, what we have is 1/4 e to the 4x. Okay, we don't have the same we started with, so you can't throw away that 4. So what's the antiderivative of e to the 4x again?
It's e to the 4x over 4, so would it just be e to the 4x over 16?
Uh-huh. Minus what?
Minus x squared over 2. And then
Plus or minus on the sign term?
it would be minus, I think.
Yep. Because the derivative of cosine is minus. So it's cosine of what?
4x over 16 again.
And let's just take the derivative of that. You get positive sine of 4x times 4, which would be sine of 4x over 4.
And then it would just reduce to sine 4x over 4. And then that'd just be 6 3/4 x.
Plus c. Whenever we're doing these problems, we need that c, because you can't go to the next step without that c.
Yep.
Okay. What's the next step?
Then we do f of 0 equals 4. Which equals. And then you would do e to the 0 over 16 minus 0 over 2 minus cosine 0 over 16, and then
What is cosine of 0? In other words, you can turn that into a number.
1/16.
Okay.
And then that'd just be plus 0 plus c.
Okay, so now we simplify. We've got 4 equals 1/16 minus 1/16 plus c. C is equal to 4. There's our function. And they'll frequently give you this kind of this problem, only they will frame it in terms of acceleration and velocity. In other words, they'll give you the acceleration function, and then they'll tell you what an initial condition on the velocity is, then you calculate the velocity function, and then you calculate the original position function, and they'll give you with the initial condition on the position function. So that's a very typical problem in calculus that I'm sure you're going to run into sooner than later. But you do them all exactly the same way. That's why the first one puzzles me a little bit. I don't quite figure out how we don't have a F single prime condition. But okay, we won't worry about it.
Okay. And I think my mom was saying that we were just going to do 30 minutes today, so maybe one more problem would be okay.
Okay, that's fine. We can do 30 minutes or an hour. Either one, whatever you feel like you need.
I think we're going to go 30 minutes today, if that's all right.
Sure.
Okay. Here's one more problem. Let me erase this. My mom got me a little mini whiteboard, which I think helps a lot.
Okay, cool. So you don't have paper and pencil in front of you. You have this little mini whiteboard that
whiteboard, yeah.
Wipe clean. Okay. Similar to what I have here. I call this a whiteboard, and I've got an eraser. So.
Yeah. So here's it's just the integral, so that like long skinny s thing, yeah, and then of
that incidentally replaced. Excuse me. that replaced sigma. That was the Greek way to do integrals.
Okay.
And it gradually morphed into the integral sign.
Yeah.
As they discovered more and more about it. Okay.
And then it's 6 sine x plus 6 cosine x.
What did you follow the 6 sine x? Oh, cosine x?
Plus 6 cosine x.
Plus.
And then,
okay. Notice how important it is that it be plus and not multiply.
yeah. And then the whole thing is squared. And there's a 6 in front of the cosine as well. Yes.
Okay. Whenever you have something other than addition and subtraction, in other words, if I take away this squared, this problem is trivial because the integral of the sums is the same as the sum of the integrals. In other words, it becomes the integral of 6 sine plus the integral of 6 cosine.
Yeah.
The moment you start doing things like multiplication or squaring, becomes a different story. It's not nearly as easy to do.
Okay.
Now let me think about this one for a second. If we go ahead and square this, we are going to end up with an interesting thing that's going to have some sine squared and cosine squareds in it, and we know how to replace that with the number 1. So let's go ahead and manually square this. I can't, incidentally, use the power rule on this. I can't make it to the third, divide by 3, and then try to do something with the inside. But maybe if I square it, I might discover something interesting. Interesting thing I'm discovering is not going to be that interesting. This added to this is equal to 36.
Because the sine squared plus cosine squared.
I can factor 36 out, and yeah, sine squared plus cosine squared is equal to 1.
Okay.
So I'm going to replace all of that and this with the number 36. Now you might think that it's a much easier problem. We don't have the squaring anymore, but now we have multiplication going on there. Yeah, we can still handle this. I'm surprised they're starting with this as a problem, but okay. Now we have addition going on. What's the antiderivative of 36?
36x.
Okay. Now to figure the antiderivative of that, first of all, you can factor out all constants. So for starters, I'm going to turn it into that. You cannot factor out variables, but you can factor out numbers.
Okay.
With me?
Yep.
Okay, that's easy. Now I got to figure out what's the integral of sine cosine. Well, apparently they've just gotten to U substitution. Does that name sound familiar for integration?
Yeah, we did a lesson on that.
There are like 7 techniques of integration. It's not like differentiation. You don't have 4 specific rules that will allow you to differentiate anything. With integration, it is about 5 times harder. And when you have stuff like multiplication taking place, the first technique that they're going to teach you is integration by substitution. And what you're looking for when you have integration by substitution is f of x next to f prime of x. Okay? And then I can use the power rule, and that's what we're looking at right there. Excuse me, let me make that g of x, different function. No, it should be f of x. I was right the first time. In other words, you look for this pattern recognition. And this is one of the first patterns they want you to look for. Well, that's what we have here. We have f of x, and that is the first derivative of f of x. Okay? Whenever we have this, we can use the power rule on this. In other words, I can now say that that is sine squared of x divided by 2, and that's actually the antiderivative of that. Notice why. I don't want to really erase that, because that's what we're looking for, is f of x times f prime of x. Whenever they're next to one another, you can use the power rule on that. Notice why. Take the derivative of this.
It would be...
Start with the power rule.
Yes, 2 sine of x over 2, so it would just be sine of x.
Multiplied by the derivative of the inside. You have to use the chain rule also. And the inside in this case is sine x. And that's very tricky. We haven't spent much time talking about the chain rule, you and I. You were kind of beyond that when I first started working with you. But the only tough part of the chain rule is to figure out what the inside is. And this inside is sine x. So the derivative of the inside would be cosine x. The 2's cancel, and I get what I started with.
Okay.
Okay? So, I mean, this was an unfortunate problem to have as our final problem, because this is a whole new subject, and not a particularly easy one at that. But this also works if I had something like sine cubed times cosine. I haven't written this properly. This should be g of f of x, composite function, times f prime of x. This is the pattern recognition you're looking for. Okay? Notice that I have it here. In other words, this is a composite function. F of x is sine of x, and g is x cubed. Okay? So that is my g of f of x, but the derivative of the inside is f prime of x. So if I wanted to find the antiderivative of this, I can basically use the power rule. Sine to the 4th of x divided by 4. That's the answer. In other words, this part took care of multiplying the derivative by the inside. Now, there's a prettier way to show you this using U substitution. And I wish I had time to do it, but we can maybe talk about that next Sunday.
Okay.
It's definitely something I'd like to cover with you. I didn't solve this by using U substitution, but that's the best way to understand it, is if I would have used U substitution. But the actual secret is recognizing that whenever you have a composite function multiplied by the derivative of the inside, then you can use power rule.
Okay.
That's an easy way to integrate, believe it or not. They get a whole lot tougher. Every technique becomes harder and harder.
Okay.
Okay, Luke?
All right.
Okay. I recorded most of this, which I'll turn